right, well, first things first, if you can't hear me, you need to make sure you turn up the volume on your computer. There is audio to this, and you will definitely need to hear the audio as we go through this and as we take notes. So please make sure that you can hear what I'm saying and have your volume turned up. We're going to be talking today about systems of equations. Today's just the first day, so we're doing basic systems. You should have in front of you, you need a pencil or something to write with, and you need your guided notes that you should have gotten from the sub. So make sure that you have both a pencil and guided notes. You might also want a calculator to use when we do some of these examples. All right, so make sure you have all this stuff so that we can get started taking some notes over systems of equations. Just hit pause if you don't have these materials. All right, first of all, we need to talk about what systems of equations are. Systems of linear equations. A system consists of two or more linear equations containing two or more variables. So you're filling in a blank right here of system. Okay, so we have two or more equations. Mostly we're going to deal with two equations in this chapter because it's new to us. And we have two or more variables. So we're going to have x and y now in all of our equations or in all of our systems instead of just x or just y or some other letter. All right, a solution of a system is an ordered pair, that's a blank you need to fill in, ordered pair, x, y, that satisfies both equations, and that's another blank you need to fill in. All right, so all of our answers are going to be looking like this, an ordered pair, x and y. So we're going to be finding two values instead of just one value as we solve these systems. Okay. The first thing that we're going to talk about here is how to actually check to see if the solution to a system is the right solution. Okay, so here we're asking, is 4, 5 a solution of this system of equations? And we see two or more equations with two or more variables. So this is what a system of equations looks like. This is what the solution of a system looks like. And we're just going to check and see, do these two numbers work in both of the equations? So we know ordered pairs always go x and then y. So I'm going to label those x and y. And I'm going to plug in 4 for x in both equations, and I'm going to plug in 5 for y in both equations. All right, so I'll work on this one over here. So instead of x, I'm going to put in 4 minus 3, and that's part of the equation, times 5, okay, equals negative 11. And I hope that it will come out to equal negative 11. So I'm going to grab my calculator, okay, and I'm going to type this side into my graphing calculator. 4 minus 3 times 5. And I got negative 11, which is what I wanted. So negative 11 equals negative 11. And I'm going to put a check mark. It worked in that equation. So far, so good. Okay, but we have to check it in both equations. Don't forget that. You have to check it in both equations. All right, so now we'll try this one. Negative 2, and again, I'm going to plug in 4 for x, plus 3, and I'm going to plug in 5 for y, equals 5. And we hope that that will come out to be true. So we're going to test it again. All right, so negative 2 parentheses 4 plus 3 parentheses 5. Okay, and I'm going to hit enter. And I got 7. Okay, so I'm just going to double check and make sure I typed it in right. Negative 2, 4 plus 3 parentheses 5. Okay, so I got 7 equals 5. Right, well, that is not a true statement. So it did not work for that second equation. So I'm going to go back to my question. Is 4, 5 a solution to this system? The answer is no, it's not a solution because it did not work in both of the equations. All right, let's try another one of those and just see how it goes. All right, and if you can work ahead of me and when you're testing these out, that would be great. Otherwise, just follow along here with me. Okay, so again, we're asked the same kind of question. Is 1, 3 a solution of this system? And we see we have two equations with two variables in each equation. Okay, again, ordered pairs are always x and then y, and we're going to take x and y and plug them into the right places for these equations, and we need to check them in both equations. So here I'm going to plug in 3 for y equals 5 parentheses 1 for x minus 2, and now I'm just going to type that in my calculator. Okay, 5 times 1 minus 2, and I got 3. So 3 equals 3, and that one worked. So now we need to check the other one. All right, again, I'm plugging in 3 for y. Now, make sure you see this negative sign right here. It is negative 1, right, for x. So it's not just 1, it's negative 1, or the opposite of 1, plus 4. Okay, and so now I'm going to test that in my calculator. Okay, -1 plus 4, and I got 3, so 3 equals 3. It worked in that equation also. So when I go back to my equation, is 1, 3 a solution of the system? It worked in the first equation and it worked in the second equation. So the answer is yes, that is the solution to that system of equations. Okay, so we can always check. You will actually be able to do this with every problem that you work in this chapter, where you check your solution to make sure that it is the right solution. Okay, so we're just testing to see if those numbers work in both equations. And that's the big thing to remember, is you have to test it in both equations to know for sure. All right, the next thing we're going to take a look at is solving systems from a graph. All right, so we're not going to actually make any graphs in this chapter. What we're going to do is just look at graphs and decide, is this the solution, or what is the solution from this graph? So what we see here is we have two equations once again. Okay, so there's my two equations, my two variables, and I see that the lines are already graphed down here. So here's one of the lines, and then here's the other line, whoops, that is graphed right here. Okay, the point that I'm looking for is the intersection point. Okay, we remember that our solutions are all going to be ordered pairs, x, y ordered pairs. Well, our solution is an xy ordered pair that is true for both equations. And so what I'm looking for is the point on the graph where these two lines intersect, or the point that is true for both equations. Okay, so I'm going to write down my ordered pair. We always go x first and then y. So x is 1, 2, 3 to the right, so that's positive 3. And y is 1, 2, 3, 4 up, so my solution is 3, 4. Okay, and you could check that solution by plugging it back into these equations and seeing that it works. Okay, so that is something you could do. We're not going to take that time right this second, but that is something you could do to make sure you had the correct ordered pair. Okay, so let's look over here at this one. I've got my two equations. Here's one of the lines, and here's the other, okay? And I'm looking for this intersection point. So think about what that ordered pair is. All right, so I go left 1, so that is -1, and I go up 1, 2, 3, so that is positive 3. So my solution from a graph is pretty easy to find. I'm just looking for that point where they intersect. You just have to be really careful. Always go left and right first in the x direction, up and down is the second number. Okay, and know that if you go left or down, it's going to be a negative number. All right, so looking for that intersection point when we're solving from a graph. All right, the last type of problems we're going to do today are called, we're just calling them basic systems is what I like to call them. All right, in this situation, you're told the value for one of the variables already. So like if you see here, y equals 11. Over here, you have y equals -4. You know the value of one of the variables. Now what you're going to need to do is take that value and plug it in. It depends on what variable it is. This is y, so I'm going to plug it in for y in the other equation. Okay, so I'm going to take this number, plug it in here, and then I need to solve for whatever variable is left over. Okay, so let's start out. Instead of y, I'm going to put in 11 equals 2x plus 3. All right, now this is a little equation that we should know how to solve at this point. I see adding 3, multiplying by 2, so I know I need to subtract 3 first on each side. 11 minus 3, and if you need a calculator, you should be using that, is 8 equals 2x. Then I see multiplying by 2, so I know I need to divide each side by 2. So x equals, oops, not a comma, x equals 4. Okay, so 4 for x. And then I already know what y equals. It was 11. All right, and we remember when we're solving systems, our answers are always going to look like an xy ordered pair. So here at the very bottom, instead of just solving for x, I need to give my final answer, which is always x and then y, so 4, and then y is 11. So 4, 11 is the solution to that system. And I could test that out by coming back up here and plugging x and y in. So for instance, I could say 11 equals 2 times 4 plus 3. And I could type 2 times 4 plus 3 in my calculator and make sure I got 11. So I double checked my answer and it did work, so I know that I have the right answer right there. All right, let's try another one. All right, here we're told y equals -4. And what might be a good idea to do right here is to hit pause and try this one on your own. And then when you have an answer, double check and see, watch the video and see if it works. So if you hit pause right here, work out this example, and then check and see if we agree in just a second. All right, so I'm going to take this -4, and I'm going to plug it in where I see y, because it's what y equals. So -4 equals -6x plus 8. Okay, this one's a little trickier. It's got some negatives and things, so we just have to be really careful. I'm going to subtract 8 on each side. -4 minus 8, we always kind of mess up here. I owe you $4 and then I owe you 8 more is going to be -12 equals -6x. Divide both sides by -6. Negative divided by negative is going to be positive, and 12 divided by 6 is 2. So x is 2. All right, so now I need to remember to write my answer, my solution, as an ordered pair. So my answer is 2, and then my y value was up here, -4. Always x and then y. Okay, so that is solving basic systems. We're going to work a couple more just to make sure that we've got it. All right, and then you'll have an assignment that you need to work on. All right, these problems are a little trickier. The equations that you have here are just set up a little bit differently, where the x and y are together on the same side. So they're a little trickier, but they're really not too bad. All right, we're still given what y equals, so we're going to take that value and plug it in place of y right here. All right, so we're going to rewrite this equation, but instead of y, we're going to plug in 6. So 5x plus 2 parentheses 6. It's not 26, it's 2 times 6 equals 32. Okay, so 2 times 6, I'm going to go ahead and simplify that. I'm going to go ahead and do that multiplication. So 5x plus 12 equals 32. Now we just have a basic little equation here. So minus 12 on each side. 5x equals 20. Divide both sides by 5, and we get x equals 4. Okay, but that's not our solution. That's part of our solution. We now need to put these together as an ordered pair. 4 for the x value, 6 for the y value. So 4, 6 is our solution. And again, we could check that up here. 5 times 4 plus 2 times 6, and make sure 5 times 4 plus 2 times 6, make sure that that comes out to be 32. And then we're 100% sure that we have the right answer. All right, one last example. This time it's a little different though. All the other examples we've had what y equals. This time we have what x equals. All right, so we do it the exact same way, but instead of plugging in for y, we're going to plug this in place of x, because it's what x equals. All right, so here we go. So -7, and then x is also -7. So -7 times -7 minus 3y equals 52. All right, I'm going to go ahead and do this multiplication right here. -7 times -7 is positive 49 minus 3y equals 52. This is a little trickier equation to solve here, but most of you are doing a really good job and are able to do this. We're going to move this 49 next, so it's a positive 49, so we need to subtract 49 on each side. Okay, don't forget that this is a negative 3y that's left over. Okay, and 52 minus 49, you might need to do that in a calculator, but that comes out to be positive 3. Divide both sides by -3, so y equals positive divided by negative. I know it's going to be negative, and 3 divided by 3 is 1. All right, now you just got to make sure that you put your numbers in your ordered pair correctly. X is always first, so we're going to take this x value first, -7, and the y value comes next, -1. All right, so then we're going to box up our answers so we have no doubt. You could take these numbers, plug them back in, and make sure it comes out to be 52. Okay, re-watch this video if there's anything that you're not sure about or anything that you need to go back over, or when you get the assignment, if there's something that confuses you, look back over this video and make sure that you understand all the material. Okay, this is something that you will be responsible for knowing tomorrow. So it's not something that we're going to reteach tomorrow. So please make sure you know this material. All right, bye.